So the topic is object reference. And it's not new because we've been saying like this when we first see arrays, when we first see string, right? We're basically saying the object type variables. So when you're doing like int square bracket a as like int array a equals to new int, and then you give a length 10, right? Whenever you do that, that a, the int array is an object type. The same with string, same with array list, same with any classes that you implemented, right? Those are all object types. And those variables, so when we're doing int array A or my string A, my array list B, those variables A and B, those are memory addresses. Those doesn't represent the value in the object. Those are simply memory pointers to say that's where the values are stored, right? Like we talked about for string, we don't know how long the string can be. That's why it's impossible to pre-reserve a set amount of memory to say, oh, here is your string. But rather, after you put in the whole string, like it might be a book, it might be just one letter, it might be even empty, right? But unless you put in the whole string, Java won't be able to know how much memory to allocate. Therefore, the variable A is just saying, oh, that's the memory address where the string will start. And we don't know when it will end now. And then once you put in the value, like if you copy paste the whole Bible in it, then you know how long it is in the memory, right? But before that, it's just a memory address to say, that's the beginning of the string. And then in the following memories are all of its values. And in some case, if you just do string A without giving a value, then Java doesn't even know which memory to point to, right? If you just simply do string A semicolon, then A is null, right? The point of null is that there's no memory reference. That's why you cannot do int A equals to null, right? Because primitive types are all values, whereas object types are memory addresses, right? And then the reason primitive types are values is because primitive types like the int, the char, the boolean, what else? Like long, double, right? All those things have fixed length, right? Int is 4 byte, double is 8 byte. So when you declare int, we know exactly how long it's gonna be. If you have a number larger than that, well, too bad. You can't do it, right? The same thing with a double or the long integer. If you have really big number, like 100 digits, well, too bad. You can't save it in the primitive type. So those are values because we know exactly how large they are. Whereas for array, string, array, list, like those all can have variable sizes. The same thing with the classes that you created, right? You can add variables, subtract variables. You can do all of those things. So there's no telling when you are creating your class how much memory is needed. That's why all those object types variables are just memory addresses. They point to where the values in the array, in the string, are stored. But the variables are not the value themselves. So that's the very important part. And we've seen something like that, right? Before, I emphasized several times that when you were comparing strings, you cannot use double equal, right? It won't work because when you're doing the double equal, you're comparing memory addresses. So let's look at this example over here. if we have string A equals to hello, string B equals new string hello, right? At this point, we know that B with this new string, it creates a new string object. So if we print A and B, and then if we print A equals to B, we can see that A concatenate with B is hello, hello, right? That means A and B are same in value. But if we do A equals to B, then it's false because A is one string object and B is another string object. They're pointing to different memory addresses. That's why you don't do equal, you use dot equals or content equal. I really don't know what that content equal is that Eclipse desperately want me to do. That's why you do A dot equals B. That gives a true when you're trying to evaluate the value of the two string, but not memory addresses. So we've seen something like this before. Now we're just simply generalize it. So not only string, right? Array is the same. Your object that you created, like my object A, my object B, if they're doing, whether A equals to B, they're comparing the memory addresses. Now they're not comparing the values. So what can you do when you are actually trying to compare values inside the object? Well, you have to implement your own equals method. So string has equals, right? That's because whoever wrote Java wrote the method for us. But if you have your own class called myObject, and you actually want to compare whether the values, the data stored in my object A and my object B are the same, you have to implement your own equals method. So in this case, my object is has two variables, int x, int y, and then public boolean equals my object other, right? You're comparing with other my objects, and then you are simply just return this dot x equals to other dot x, and this dot y equals to other dot y, right? So if this x equals to the other x, and this y equals to the other y, well, then that means they're the same, right? But in the memory, my object A and B are actually two different things. Only their value x, y are the same because you implement your equals this way. And then again, there's no, like, this equals is not something that's like a special function, special treatment. No, you can implement this any way you want. Like if you only think x is important but not y, so as long as x is equal, then y doesn't really matter. Well, you can just simply return this x equals to other x. So it's all based on your own application, really. So this equals, when you are implementing it, is nothing special. You can have any logic that you want in there. But obviously for string, the equals is pretty clear cut, right? That means every letter is the same. But for some abstract thing like my object, you can define it any way you want. Maybe you can even define it if x mod y equals to other x mod other y, then they're equal, right? It's anything you want. But the takeaway is when you are comparing object, if you simply do object A equals to object B, then you are still comparing memory addresses, whether those two references are equal, because all object variables are memory references. So if you simply do equal equal, then you're comparing the integer number of their address location. If you want to see whether their values are equal, you have to implement your own method to do that. Is there any questions so far? This is things that we've seen before, especially with strings, right? We said it many times, string that you're not supposed to do equal, you're really supposed to use string dot equals. And turns out the same for everything. The same for arrays, same for array list, same for your own class. So is there any question on this? Okay. I'm gonna move on if there's no question. Is anybody paying attention? How about this? What am I playing right now? Okay, good. Okay. I figured like if I have a streamer playing, maybe it will get people's attention from time to time. Okay, well then I'm gonna move on. So knowing that all object variables are memory references, then there is a direct implication on the behavior of your variables when you are passing them in to your methods. So the difference is called pass-in value versus pass-in reference. So if you look at this implementation, we have this public static void method, just any method that has int A, string B in my object C in there. And then the code is A, I just increment. B, I just want to append the string world to it. And C is my object, so I want to do C.x increment and C.y increment. And then when I call this function, I'm using those three variables. So int A equals to 5, string B equals to hello, my object C equals to new, my object. I forgot parentheses back there. And then I just simply call method ABC. So what's going to happen? What's going to happen? What's going to happen after I call ABC? What if I print out the values of A, B, and C? Well, let's check it out. So here I have my ABC, right? A is 0, B is hello, C is my object 1, 2. And then this is my object, by the way. Again, it's just int x, int y. And then I have a constructor that takes in A and B, which x equals to A, y equals to B. And then I have a toString, basically just print my class, my object, x equals to x, y equals to y. So it's very simple. My object is very, very simple. So now we go to main class. What's going on is I have integer A, I have a string B, I have object C. And I call this method, right? A++ B equals to hello world. Well, this is B equals to, but this should be B append with the word world. And then C.x++, C.y++. And then after I call this method, I'm simply printing out the value, A, B, and C toString, right? C toString basically just prints out the X value and Y value of my object. So let's run. So A is still 0, which kind of makes sense, right? B is still hello, which also kind of makes sense. But C was initialized to be 1 and 2. Now after method, it becomes 2 and 3, right? Here, my object C is 1 and 2. But after my c.x plus plus, c.y plus plus, after the method being called, a and b is not affected. But c is showing its value actually was altered by this method. So what is going on? Well, turns out when you pass in value, well, this is what we observe, right? Primitive types and string becomes a copy of passed in variable. What does it mean? So if you print them out here, a plus b, maybe plus c dot to string, right? Let's see what's going on. So if you print them out inside the method, we can see a is 1, b is hello world, c is my object 2 and 3. But after this, right, after we print out whatever is in the method, we come out here, we print out the same a that's being passed in, the same b is being passed in, the same c is being passed in. We see a is not actually affected outside the method, right? Inside the method is 1 because we did a plus plus. But outside of it, after we run the method, a is still 0 and b is still hello instead of hello world. Only c again is affected. C becomes x equals to 2, y equals to 3. And it's the same as inside the method, x equals to 2, y equals to 3. So it seems primitive types and string actually have a copy of itself inside of the function, right? And whatever is done inside the function is just done inside the function. But objects other than string, right? Remember, string is also an object. Object other than string seems to remain to be the same object, right? This c being passed in, it was getting incremented here. And after the method, it remains to be incremented, right? It's still 2 and 3. It didn't revert back to 0, didn't revert back to hello. So why is that? This is what we observe. And the reason is primitive type variables are values, not reference in Java, right? So when you pass in the 0, it literally is a 0 in here. And when you're doing a plus plus, so this is basically a equals to a plus 1, right? When you are doing that, since it's not a reference, is you do not point to where the original a is stored. You indeed get a copy of the value, 0. And you are incrementing based on that copy. So when primitive passed in, when you're passing in a value, a primitive value, Java creates a copy of it and then do action based on the copy. That's why outside of this, a remains the same. That original value remains the same. Whereas the copy value inside the method is incremented to 1. There, incremented to 1. Now, what about string? String is an object. We all know that, right? So it should be a reference to the memory, right? This string should kind of behave the same like C since they're all object. But why, when we print out the new string, the string B is hello world inside the method, whereas outside, after the method, the B is still hello? Well, turns out string is something called a immutable object. That means once you make a string, you cannot change it. So when you are doing string b equals to hello and b equals to b plus world, after you've done b plus world, b is actually a new string object that has value hello world in it. And then the original b, hello, is actually a different thing that is forgotten. So basically what's going on here? Here, let me show you something strange. B equals to hello, right? Immutable, that means it cannot be changed. String C equals to B, right? When I do this, I'm saying, okay, B points to the memory address that saves hello. And now I'm gonna point C to the same memory address to be B, right? So when I print this thing out, system out print line, C equals to B. What's gonna happen? It's true, right? Because I mean, C equals to B. They're literally the same. All right, now, or B equals to B plus world. So by our logic for objects, right? If C and B points to the same hello, and when B is changed in the memory, then C should also change with B, right? Since C and B are pointing to the same thing. But string is a little bit weird. If you look at C equals to B now, they're different now after I append world. This is all because string is immutable, meaning it cannot be changed. And when you are trying to change the string, what Java does is in the background, Java actually create a new string every time when you are trying to change something about the old string. So now B is a new object with a new memory. That's why the first time when C equals to B, C and B are the same in memory address as intended. That's why the first time is true. But when I start changing B, B is not supposed to be changed. Java only give you this kind of like illusion that string can be changed. But actually in the background, Java create a new string object, copy the hello over, and append the world to it. So now B is a totally different object now. That's why the second time when I do C equals to B is a false. So they're pointing to two different objects. Isn't this weird? This is very weird, actually. C++ is not like this. But in Java, string cannot be changed. Once you change the string, it's a new string. It's actually a new string. So every time before when we did like string and in the for loop, you are doing string plus equals to like a row of numbers, right? In project 2, every time the for loop runs, you're creating a new string. Yeah, there is a way to. So string is only, yeah, string, well, actually all the objects that are immutable have the same. So if you just search Java immutable objects, there's a bunch. See, there's like a bunch. Well, they actually didn't say much. Immutable objects. Yeah, basically object to consider immutable cannot be changed. So basically you can even create your own object. But for now we know string is immutable. There's also other immutable things. Like if you create your object public final, when you have final modifier in there, that makes this X immutable. Once you set it, you cannot change it. And in your own class, you just absolutely cannot change it. But for string, because string is such a common thing, right? And all the other modern languages support string like concatenation and operation on string. So Java cannot back down from that. That's why Java implement like this special string thing, right? Where when you modify the string, Java creates a new string in the background. But for your own object that you create as immutable, you cannot do this simply because you didn't write the Java language. I mean, if you're not agree with this, well, now it's kind of too late because now Java belongs to Oracle. But when it was open source, you could be like, hey, I want my own object to behave the same thing like string. Like you're able to do that. So the thing that you know of and use often right now is only string. There's no other object that we know or use often. So string is the only exception for now. To be honest, I never used any other immutable object than string. So I actually don't know whether there's other things exist. You might have to look into Wikipedia or something. But because string is immutable, that's why when we create a method, when we are modifying this B, right? When we pass in this B, when we just pass into the method, this B is the same as the B up here. But as soon as we append a word to it, this B now is different from this B. Those are two different B's now. That's why inside the method, when I print this B, oh, why do I have an error? Oh, forgot to delete that comment. That's why inside the method, when I print out this B, it says hello world. But once the method ends, right, the scope of the variable finishes, right? Remember, all the variables that you declared inside a function is not available outside. So since B now, it's a new thing, it's a new string. So as soon as the function is over, B is forgotten. But this B remains the same. So for primitive type and string, when you pass in something, when you change them, they become a copy of itself. But the reasons are different because the primitive type, you're passing in a value. And in the function, you're working on that copy of that value. Whereas string, you're passing in a reference, but string is immutable. So as long as you don't change the string, you are using the same string that's being passed in. But as soon as you modify it, like here, then you're actually working on a copy. It's just Java took care of it in the background that you don't see. But you're actually, like Java actually made a copy of the string B and modified it. But for object C, now we finally get to the object that has a consequence when you're modifying it. So for object C, this is a reference. So while it's a thin line, actually. Some people call this pass in by reference. Some people still say this is pass in by value, in that you're passing in the memory location as value. That's why they're saying, oh, that's the same as value. But then the same argument can be said about any other languages. Like they always say C++ is passed in by reference. No, it's also passed in by memory address. So pass in by reference by their definition doesn't exist. So if some of the interviewer is trying to pull that kind of BS on you, you can just lecture them about that. Just tell them that, hey, I know what I'm talking about. If you think this is passed by value, then everything is passing by value. Okay, so ignore that. So when we are passing in an object, because object variables are referenced to memory locations. So this C is pointing, is an integer value that is the physical location inside the memory where your object is stored. So it doesn't matter if the C's integer is copied or not. When you are accessing this object, Java goes to that memory location, right? Doesn't matter this physical memory location is copied or not. But they're all gonna point to the same spot in the memory. So when you're doing C.X++, they're saying, oh, in that memory spot, look for this variable X and increment it. In this memory spot, look for this variable Y and increment it. That's why inside the function, you see them increment, but outside of the function, since this C and the C in here points to the same spot, that's why out here saying, what is the C's toString, which is basically its X and Y, right? What is C's XY? Well, they're pointing to the same XY in memory. That's why this is passed in by reference. So the code, your object outside of the method is affected. Whereas for integer, for primitive type, your variable outside of the method is not being affected. For string, is not affected for a different reason because string is immutable. For all the other object, the outside variable is actually affected when you are working on it inside the method because they both point to the same memory address. So that's the very important and confusing concept. So all other object types, those variables are referenced to the memory address. So when you're passing in that physical value of the integer value of the physical location, those value points to the same place. So let's just look at the demonstration. So here is what's happening, right? In the code, we have 3A, 5B is hello. This should be C. C equals to new object. And then when I call method ABC, what's going on? 5 is passed in as a value. Whereas hello in my object both passed in as references. So 5 is literally put into the method. Whereas string B, your 1, 2, 3, 4, 5, 6, 7, 8, the memory address is passed in. And the same with my object C is 1, 2, 3, 4, 7, 8, 9, 0 is passed in. And what happens when you're working on this variables? Well, because 5 is literally passed in, so Java created a temporary copy of 5. So when you are doing 5++, Java is actually creating a new variable that put in your 6 into the memory. And B is the same. Even though B is a string, is passing in by reference, but because string is immutable, so it's the same behavior. Java create a new copy of B, or not really a copy, but a new string. It literally is a new string object, and put in the value hello world in it. So now B is in a different place. See, original B is here, now B is here. But when my object C is passed in, because C is referring to this memory, so when you're doing C.X++, what's being affected, it's still my object C inside the memory. There should be C. So it's actually this C's X being incremented and this C's Y being incremented. That's why even outside of the function, your variable is affected. That's the return. Is there any question on this? I mean, we can see more examples. So if we look at this example, and this is how it affects how we code with objects. So we have a class called pass-in reference, and this is how it's implemented. So pass-in reference has 5 variables. We got an integer A, we have a char B, we have a string C, integer array D, array list integer E, and the my object F. And then you have public void set value. So basically, I passed in 5 things according to our variable A, B, C, D, E, F. And then I just simply saying this A is A, this B is B, C is C, D is E, E is E, F is F, right? So what happens if I do PIR.setValue? So this is functions called setValue. When we do that, there's an error. Why? Oh, it's because duplicate. Yeah, I need to comment these out. Let me comment these out. There we go. So we run this. There's still an error. Because comments. We run this. There we go. So we put A equals 0 in there, right? So the toString method is simply just print out the values of each of the variables. So after I call PR set values, A is 0, B is the letter Z, C is string hello, D is a integer array that has 6, 7, 8, 9, 10 in it, and then E is a array list with 1 number added, and then F is my object with X equals to 5, Y equals to 6, right? Everything looks good. So now, as you're using this in the main method, right, you start coding and then you kind of lost track. And then what happened is you made some changes to your variables. So maybe later on, A becomes 1, B becomes Y, and C becomes hello world. And the first element of D, instead of 6, now is 5. And your array list is added by 2. And then your object F, X now is 100 and Y is 200. So remember, you did all that. You did all of this inside the main method, right? You didn't interact with your pass-in reference object at all. Like it might just be unrelated code with your object, right? You're just like trying to change some values. Maybe user put in some new input and you're trying to make changes. So you haven't interact with your object at all and see what happens. Before, those are the values, right? And now those are the values. So A is still 0. B is still Z. C is still hello. Now D becomes 5, 7, 8, 9, 10 instead of 6, 7, 8, 9, 10. E is 1, 2 instead of 1. And your my object X becomes 100, Y becomes 200 instead of 5, 6. So you didn't interact with your PIR object at all, right? I'm just simply changing those values. But because here you passed in those values, you passed A and B as values, right? Because those are primitive types, those are integers and char. So these are unaffected. String, although you pass in reference, but after you change the string, it becomes a new string. So string is also not affected. But all the other ones, the array list, the class you implemented, because you passed in by reference to your class. Now, if you change them outside of your class, outside of your passed in reference object, the value, because you passed in the same memory location to your PIR object. So now your PIR is changed, intentionally or not, right? And this can be devastating, right? Because you are coding something that's totally unrelated with PIR. Maybe like the user add another 2 in it, and then now you're like, oh yeah, I need to add another 2. But now your PIR is different because you pass in the same reference with the array list here and here into your PIR object.
That's
why,
wait, Java which one to pick?
Huh?
Is there a way of telling Java which one to pick?
Yes, there is. So if you don't want this unintentional, like sometimes it might be intentional, right? Sometimes it might be, oh, since I changed this, I want this to change. But if you don't want this to change because of some unrelated code, you can do something called deep set value, or I just call it deep values. So why is this deep? This is deep because for every one of those things, I create a new copy of it. Whether it's value, it's reference, I create a new copy of it. So A equals to A, well, since A is integer array, A is integer, so Java is gonna create a new copy. So Java took care of it for me. I don't have to worry. B is character, same thing, Java's gonna take care of for it. I don't worry. C, string, Java cannot do it. You can do this in Java, but you cannot do this in C++. So in Java, you can do it, but if you really want to be safe, you want to create a new string C. This way, C will be a new, completely new object for sure. And then when it comes to the integer array, I actually create an integer array. And then I copy the value of the old array over. For array list, same thing. I create a new array list and I copied the values over. So e.add, this.e.add, e.get I, right? This gets to the ith value in here, and then I just add it back onto our e. And then for f is my object. So I create a new my object with my object constructor that put in fx and fy, f.x and f.y. Now, remember f.x and f.y are integers, right? My object, those are integers. So it is safe to do it here. If f.y is array, then this constructor is not safe anymore, because then you're passing in the reference of y again. But since both are integers, I can safely say f.x, f.y, because those integer value will be copied. And then on top of this copied two integers, I'm creating a new my object. So everything here, whether it's Java taking care of for us, or we're creating a brand new object of the same type, right? Whether it's array of int or array list integer, we create a brand new object using the new keyword. And then we copy things over. So what happens now? If instead I do PIR the set values, if I do PIR dot deep values, now you can see things are the same, right? Before the change, after the change is 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 1, 1, object x equals to 5, y equal to 6. So to answer the question, can you pick a way for Java to tell you? Well, technically, no. Technically, you cannot tell Java, oh, I want to do the copy versus I want to do the reference. But really, you have to write your own code. So there's not like a one switch saying, oh, I'm passing in reference or passing in value now. But you have to write your own code to make sure when you don't want the reference to the same variable, you have to create a new one. And then copy the value over. Does that make sense?
Does this work the same way if you want the new print or the PIR.toString to show the new values that you set that aren't being shown?
Oh, well, if you want to see, so you mean if you want this number to actually be changed, right? Is that what you're
I
saying?
mean, like, can you scroll down in the print window or whatever it's called at the bottom,
This
where everything's
two
printed
string?
out? What's it? The console?
Oh, like here, system output line PR
No,
two
the
string.
console at the bottom of your whole screen.
Oh, this. Oh, okay.
Scroll down. So okay, yeah. If you want A to say 1, can you do the same thing?
Well, if you want A to be 1, then you have to do PIR dot A equals to 1. That's the only way.
Oh, okay.
See, now A is 1.
Gotcha.
Because this A is different from this A because it's a value. It's being copied every time you pass into something. But for reference, if you don't do the deep copying, right? If you don't create a new object, then the DEF are this D, this E, this F is the same as this. It's the same as these. So everything just got tangled together. That's why when you're doing something that's unrelated to PIR, you might like accidentally alter your code. And that is why last class, if you remember last Friday when we did the sample, I insist on copying over the double values. It's the same thing, right? I want to make sure that once I get the data from the file, this sample will not be changed, right? I don't want to like, after I create this sample, then maybe outside of maybe in the main method, I did something with the value, and now not unknowingly, I actually altered my sample, right? I don't want that to happen. That's why I did this deep kind of copy, right? I have the values to be new double 4, and then I just copy the value from outside to the inside instead of doing this dot values equal to values, right? If you do this, if you have any action outside of your sample class on this value, it's going to affect your sample value. And I don't want that to happen, right? Because the sample shouldn't be modified so easy. So it's the same concept here. If you don't want this thing to change, then you have to use the deep version of the set values when you know that the parameters you pass in are objects. because they will be references and they will be all point to the same thing if you don't use the new. Keyword. Is there any questions? Yeah, it can be pretty confusing sometimes. But this opens to the door to some nice things. So for instance, let's look at this. So let's say after I set the deep value A, B, C, D, E, F, right? And then I call this PIR.multiply array D. So what's happening here? Or I can create a new array. Three, four, five. So instead of D, let's use M. So I create a new array M that has 3, 4, 5 in here, and then I did PIR multiply array M, and then I print out the M using the array as toString method. So let's look at what multiply array is. So multiply array simply takes this integer array ARR, right? And then for every element in the ARR, I'm multiplying by A. So multiplying by this integer A I have. ARI equals to ARI times A. So what's happening now? Let's change this. Let's don't change that. So since A is 0, when I did PIR multiply array M is now old 0. See? This is because I passed M as a reference. So whatever is happening inside this method affect the M out here. So when I need to do this multiply array, when I modify the M, this M is also modified because it's the same thing. And then when I do array.toString M, they're all 0. Now to contrast this, if I copy paste this, if I just do multiply int, I'm passing int I. And then I equals to I times A. What will happen now? Int I equals to 6, PIR dot multiply int I, and then system dot out print line I. Well, what should be the answer? What should I be? Someone, please, someone paying attention who can answer this question. Looking at this, so this is multiply int. You're basically just taking this integer, multiply it by A. And then out here, I set n equals to 6. I did PIR multiply int I, and then I print out the I. What should this I be? Knowing that int is a primitive type, so you're passing in value. Well, 0 is not, yes, 6 is correct. Inside the function, yes, it's 0 times to 6. But because I is a primitive type, so you're passing in by value, meaning once the 6 gets into the multiply int function, Java creates a copy of it. So this is not affected. So let's run this. Why do I have an error? Oh. When we run this, C is 6. Because I is passing in by value, right? 6 is copied here. So this 6, the I here, different I. Totally different I. So when you do I equals to I times 6, or 6 times 0, yes, this I is 0. But once this function ends, this scope of the I finishes. So the original I is still 6. So contrasting this with passing in by reference, when you do want to have your object being affected, right? Let's say, what if this is like long amount? Right? Somebody has like 3 account that has this much long amount. And then when you're multiplying this long amount with whatever interest rate, right? Imagine if A is interest rate, then when you print out the final loan amount, that will be like the interest, which are 0. That's too good to be true, right? So when you actually want this to be changed, when you actually want something out of it, function. So you have some values in the object. You want it to be modified by a function. You can simply pass in the reference of this object. Let the function does it work. And there's nothing else you have to do because it's already a reference. So whatever the function does, it's going to be the same object. So after that, your new object will be the new modified value you want, right? So let's give a different value. Let's give a like 0.5 or something. Or not here. But if A is 0.5, then we can see like the interest. Why is there key? Oh, because it's integer. Oh, because it's int. All right, fine. Whatever. Make it 2. Yeah, see? Loan amount is this, and then maybe after some time period, then your new loan amount is 600, 800, 1,000. The other way of doing this is going to be, will just be so this is the equivalent of doing this. Or I'm going to make this 3. This is the equivalent of doing this. So long amount equal to this. See, this gives the same effect using the return. But sometimes you'll see later on that I don't have time now, but we'll see probably an example on Wednesday. Sometimes you don't want there to be return. You want everything to be handled through passing in by reference. And we'll see an example about that on Wednesday. All right, I guess I'll see you guys later. I need to delete and Control Z all of those things because the second section has to start fresh.